Hello and welcome to everyone's favorite topic, word problems. Before we begin, a little word about these word problems. You know why mathematicians have these guys? The whole problems with word problems are the words. Let me explain. Uh, in English, we'll have this bad problem of Jim and Jeff wanted to walk somewhere and blah, 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 blah. And it's filled with all these words. If there were a way to get it over into the math world, then all of a sudden everything is better. So we're going to call this over here Happy Math Land. And this is where you're a superhero. This is where your power of solving equations reigns supreme. You're over here in Mathland and you can do everything you want as long as you do it both sides of an equation. Add, subtract, multiply, divide. This is where problems become solutions. We interrupt this long exposition on word problems and math and equations and how cool math is to talk about a similar message in a very important related topic. Here's a message from Richard G. Scott talking about how difficult it can be to make decisions in life and how valuable it is when you pull out of the world and look at just the principles. Here we go. As you seek for spiritual knowledge, search for principles. Principles are concentrated truth, packaged for application to a wide variety of circumstances. A true principle makes decisions clear even under the most confusing and compelling circumstances. It is worth great effort to organize the truth we gather to simple statements of principle. Elder Richard G. Scott. Similar to how math, when you put it into equations, the problems turn into solutions. Same thing in your life. When you can put the problems of your life into statements of principle and compare them against the principles of the gospel, it makes even the toughest decisions fall apart. Okay, let's get back to the math. This is where you find those solutions. So, in order to get from the word problems over back into Mathland where you reign supreme, we're going to go through these steps, DVPE. This is how you're going to do it. Highlight the data. Try to get rid of all those superfluous words and focus on the numbers and the operations that are really going to help you. Second, you need a variable. There are numbers you don't know. And that's the whole idea of having the alphabet in math. You need the variable. You need to know what it is that you don't know. Stick it in, see what operations happen to it, and then it comes out with an answer, and you have an equation. So, next, this is the plan. So think about it. All of these different kinds of word problems that we're going to go through in this section are different plans. Can you directly translate it? Are you going to be using formulas? Is it a distance and rate problem? All of these different things that can be overwhelming right now. Think through how this number, this variable, and the other numbers go together to create an equation. And that's the last one. I'm going to put this guy in big bold. This is your end goal. Once you have an equation, you are all powerful. You know how to solve this. And so that's the goal. If you take this and travel through the data variable, think through the plan, and then write out the equation, you are in happy math land and you are free to smile at that point in the problem. You still have to finish it, but go ahead and smile right then and there. Good. The best way to learn how to do word problems is to see a bunch of them done. Do them yourselves and practice them. So we're going to go through each one of these, show you an example, and have you work through a few of them. So first type of plan we have, direct translation. Here we're going to use that language dictionary. 50 is 7 less than 3 times the sum of 11 and a number. Highlight that data. 50 is, that's going to be something, 7 less than. Do we remember what happens with the word less than? 3 times the sum of 11 and a number. Okay, can you see all that data in there? Yes. So a number in math, we got to find that variable. What is that number? Let's use N for the number. You could use X, P, L, Q, or T, or your initials if you'd like to, but we're going to use N for number. What is that number? So let's write this out. Here's our plan. Let's translate all of this. 50 is 7 less than. Now remember, that means you're taking whatever it is here and subtracting 7 from it. That's 7 less than something. So less than 3 times the sum. What does the sum mean? Sum of 11 and a number, that is 11 plus n. So we've got to do 7 less than 3 times this thingy here. So 3 times 11 plus n. Let's read it one more time to see if we've got it. 50 is 7 less than 3 times the sum of 11 and a number. Right on, look at that. Now look at where we are. Look at where we are. Happy Math Land. This is an equation. You know how to do this. Yeah. Are there any parentheses? Indeed, we know how to take care of that. Distribute. So we got 50 equals 33 plus 3n minus 7. All right. Combine things together and we get 50 equals 33 minus 7. That's 26 plus 3n. All right, now get rid of any addition subtraction. So subtract 26 from both sides. We get 3n equals 24, and then divide by 3. And we have n equals 8. So we look back and go back into the English language, and we have 50 is 7 less than 3 times the sum of 11 and a number. What's the number? The number is 8. So the answer will just be 8. We introduce this variable n, so you can't just write n equals 8. You have to say, oh, there's our answer. And does it work? Indeed. Check it and see it works. On the next one, we have a special kind of translation. We have the word consecutive coming in. So again, let's read through it. There are two consecutive odd integers. The first one plus 2 times the second equals 139. What are the integers? Well, the data. There are 2 consecutive odd. Ooh, look at that. These are integers, and they are odd. That's important to know. The first one plus, that's going to be important. 2 times the second equals 139. What are the integers? So here's our data. 2 times equals 139. We got the numbers there. We need a variable. It says, what are the integers? So we're going to start with, say, I don't know, x. Now, remember what consecutive means. Consecutive means in a row. So if you have the number 7, the next consecutive odd integer would be 9. The next consecutive integer would have been an 8. But where it says odd, we have to skip the even one in between them. So they are x, and the next one up would be an x plus 2. 2 higher than the previous one. So here are the 2 numbers. That's picking the variable. Very important plan. Very important in getting this equation. So now the plan, let's think through it. 2 consecutive odd integers. We got them. It says the first one, x, plus 2 times the second. So 2 times, here's the second guy, x plus 2, equals 139. Now notice what we have here. Once we've thought through the plan and described it in English words, we have now turned it into, hey, look at that. Happy Math Land, we have an equation. We're all powerful here. We know how to do this. Can we solve it? Yes, we have an equation. We're in Happy Math Land. X plus, do we have parentheses? Indeed. X plus 2x plus 4 equals 139. Add these together, combine these multiple x's. 3x plus 4 equals 139. Subtract 4, we get 3x equals 135. And divide by 3, and we get x equals 45. Now notice this isn't just the answer. It says, yes, x equals 45, but notice the question said, what are the integers? We got to find both of them. So if x is 45, then x plus 2 is the next consecutive odd integer. And this is kind of neat. Math is magic. You can take this right here and say, ooh, 45 and 47. They are consecutive odd integers. If you take the first one plus 2 times the second one, that's 94, plus 45, you indeed get 139. Magic. Happy Math Land. Let's look at the next kind. For the next kind of problem, we focus on problems for which formulas have already been given to us. This is kind of an exciting time here. We can do formulas. Now remember, formulas are patterns. Patterns of how the solutions can already be obtained that somebody has gone through and established for us. And if we follow that pattern, we are sure to get the right answer. We've gone over a bunch of formulas, distance, rate, and time, percentages, stuff like that. Here, they give us the formula for compound interest. Let's use this as an example. So they give us this formula. We don't actually have to do a lot of planning in this case, or even pick the variables, because the formula has the variables established and the plan on how to get it. So we need to find out all the data and start sticking it in. So we need to find the initial value. Okay, so we do need to know a little bit about the formula. We need to find P. So P is our question mark. Okay, and we put it into a 7% interest rate account. So that means the rate is 0.07, that it compounds monthly. You've got to know about this formula enough to know that N is the number of times per year that it compounds. So N is 12, 15 years. Oh, that means T right there is 15, and $4,000 is the final amount. So $4,000 is A. Yeah, once you have those, then this is the cool thing about formulas. What do? You stick in the data, and then you're able to solve. So let's write that out. 4,000 equals P. We don't know P. 1 plus 0.07 over 12, all to the 12 times 15. Let's pull out our calculator and stick in what we can. So here we have 1 plus 0.07 divided by 12, all to the, remember parentheses on this 12 times 15 to make sure the entire bit is up in the exponent, and we get 2.8489. So 4,000 equals P times 2.8489 dot dot dot. All right, remember where we are. We're in happy math land. We can use all of our powers here. How do we get rid of that times? By dividing. Yes, indeed. 2.8489 divided by 2.8489. And we get that P equals, let's get our calculator out, and we're going to take 4,000 divided by that answer. Second answer will give us 1404.03. 1404.03. And we round to the nearest penny because we are in dollars and cents. So yeah, if you stick in $1,404.03 into a 7% account that compounds monthly for 15 years, it will turn out to be $4,000. Excellent. To the boards! All right, now it's your turn. Here are 3 problems. Go ahead and copy them down. Work through them. Pause this video while you're doing that, and then press pause, play, to get back into it. Welcome back. All right, let's do it. Translate these guys. 17, there's a number. More than is going to be a plus. Twice a number. Well, we got to pick that. Let's use, I don't know, X or N. So twice a number, that's 2n, means equals 71. Write that down. 17 plus 2n equals 71. And please note where we are. I'm going to put this right here to remind you, you just made it to happy math land, because now we know how to solve this. Subtract 17 from both sides, right? And we get 2n equals 71 minus 17 is 54. Then divide by 2, and we get n equals 27. Our number is 27. Excellent. Let's do that number 2. There are 3 consecutive integers. So first of all, consecutive, what does that mean? That means in order, and integers means we're not dealing with fractions. Oh, that's nice. We're not dealing with fractions or decimals or stuff like that. So let's write down what they are. 3 consecutive integers. We got to fix what they are. So we're going to be asking, what are the 3 numbers? So the first one, let's call it x. The next one in order would be x plus 1. That's the next consecutive integer. And then the next one would be 1 even bigger than that. So here are our 3 consecutive integers. This is good. So now it says the sum of the first 2. So that means we're going to have a plus sign between the first 2. That means equals. 15 less than, now this is subtracting 15 off of something, 3 times the largest, and that's times. Let's see if we can write that out. The sum of the first 2, so here's the first 2 of them, and we're going to sum them, which means we're going to add them. So that one plus that one is, okay, 15 less than, so that subtract 15 off of something, 3 times the largest guy. The largest one is this guy up here, x plus 2. Okay, let's make sure we got that right. The sum of the first 2 is 15 less than 3 times the largest. And if you can see that equation and see that that is the translation of that, you are indeed happy, blessed, And yeah, let's go. All right, so now we have an equation. Do we know how to deal with this? Of course we do. Put the x's together. We have 2x plus 1 equals, distribute through the parentheses, and we get 3x plus 6 minus 15. Excellent. We need to get all the x's together, so let's subtract 2x from this side, subtract 2x from this side, and we have x minus 9, just combining those two together, equals 1. You see how this falls apart once we get into math land? It's great. Add 9 to both sides and we get x equals 10. All right, so that's one of the answers. Notice what happens now, that we have 10 is x. So this guy is 10. What's the next one? 11 and 12. And what's amazing about math is it's like magic. If we say the sum of the first two, 10 and 11 is 21, is that really 15 less than 3 times the largest? 15 less than 3 times 12? 3 times 12 is 36. 15 less than 36 is 21. It's the sum of those two. These are the only sets of consecutive integers that actually work. Genius. Love it. All right, let's move on to the number 3. Using the formula for temperature conversion from Fahrenheit to Celsius, here's that formula. What is 45 degrees Celsius in Fahrenheit? Ooh, they give us the C, so this is our 45, and they gave us a formula, which means we don't have to do a lot of thinking. They've already thought through what it is, so we just need to stick this guy right up in here. So we have 45 equals 5/9 F minus 32. Now, if you can see it, some of you might be able to want to peel off that 5/9 first, and that's perfectly fine. But we're going to follow the 5/gots and go ahead and get rid of the parentheses. So we jump that in, and we have 5/9 F minus 5 times 32, that's 160 over 9 equals 45. Good. So we got rid of the parentheses. Now get rid of the fractions, and we do that by multiplying by the least common denominator. So timesing by 9, timesing by 9, timesing by 9. Good. So cancel, 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 cancel. Okay, so what do we have there? 9 times 45 is 405. If you need to stick that in your calculator. 5F minus 160. Great. So now add 160 to both sides. Plus 160. Oh, shoot. Do you see what we forgot? We forgot to recognize that we had an equation that we knew how to solve. We're in happy math land. Can't forget that. You got to feel happy when you're doing these problems. Okay, 5F equals, what is that? 565. Good. Now divide by 5. We have F is, the Fahrenheit in this case would be 113. 113 degrees. Let's write that out. 113 degrees Fahrenheit will be your answer. That's what 45 degrees is in Fahrenheit. Excellent. All right, now onward we go. Another group of word problems that has formulas attached to them are the problems involving shapes, but it's also a good idea to draw that. So here we have an example. What is the slant height of a cone that has a surface area of 587 centimeters squared? Yep, that's an area, and a radius of 8 centimeters. Now, we should draw this just to make sure we get the picture of what's going on. We have a shape, so we should do that. So here's the radius. Remember, the height is here, and the slant height is there. That's the slant height of a cone. And the surface area is covering the entire thing and covering that circle on the bottom. We may need to look that up, what that formula is, but let's look at the data first of all. 587 is the surface area, radius is 8, and we're looking for the slant height. So this guy is going to be our variable. The plan, there is a formula that comes with it. Use it. It is surface area equals pi r squared plus pi rl. That formula, that pattern has already been given to us, so let's use it. Surface area is 587. Let's put it in. Radius is 8, so that'll go in there and over here. So we have 587 centimeters squared equals pi times 8 squared plus pi times 8 times what we don't know. And that is the variable right there that we're trying to get. So let's see what we can do here. 587 equals 64 pi plus 8 pi L. If you want to put those in and get decimals, that's perfectly fine, or you can keep them just like that until the end because you can move anything you want. Notice where we are. We're in happy math land. We have an equation. We know we can do this. There's our variable. So do we have any parentheses? No. Fractions? No. Multiple L's? No. Let's then add or subtract. So subtract that 64 pi, get him all the way gone. So we get 587 minus 64 pi, and that's going to equal 8 pi L. And again, you could punch that in your calculator at any time. Feel free. Now, how do we get rid of the last piece? We've got to divide off this 8 pi. It's timesing the L. So divide off 8 pi. And so we get L equal 587 minus 64 pi over 8 pi. Let's call in that calculator. So we punch in 587 minus 64 pi divided by parentheses 8 pi. We don't want to let that pi drift to the top. It's got to stay on that bottom with the 8. And we get 15.36. 15.36. Now, before we leave, it's saying what is the slant height? This is a length. So this is one-dimensional where we are in centimeters squared and centimeters. So the answer has to be in centimeters. 15.36 centimeters. Good. That should give you an example before you go and try some on your own. Now we come to percents. In percent, there are 3 different kinds of percent word problems that can happen. The first one is a very basic one where you have something that says, hey, what is 18% of 52? And this one, it's just translation. There's 0.18 of, that's times 52. And that equals, we just punch that in and get 9.36. Now, it could say it just a little bit different and say, ooh, 18 is what percent, a question mark percent, of 52. And notice it's asking a different question here. It's saying 18 is what percent, there's our x, of 52. In this case, you actually need to use some algebra and divide by 52, and you get x equals, and you get a number here. 0.34615 something when you stick that in a calculator. And so it's saying, what is that in a percent? That is 34.6%. And that's true. If you got 18 out of 52, you would have 34.6 on the quiz. Let's look at one more different type of basic one that you'll see. And it says 18 is 52% of what? Oh, that's a good question. Now we're taking 52% of something to equal 18. And again, an equation with direct translation will work. 0.52 of what is x? So now we're going to divide by 0.52, 0.52, divide by 0.52. And we get x equals, and this one, when you stick this in a calculator, comes out exactly to 34.6. A word of caution, these two answers have a lot in common, but they are not near the same number. This x is 0.346, which turns into 34.6%. This is the actual number, 34.6. 18 is 52% of this large number, 34.6. Okay, now let's try when percents change. The stock market does this. The world works on percent increases and decreases, on markups and sales tax and such. So these are probably some of the most important problems you will ever see. So let's use one for forward and then one for backward. Here we go. Now we've accomplished basic. We can forget that. So forward. It says a 15% tip was added to a meal. The original cost, this is the original one, was $35.17. What was the final cost with the tip added on? So what happens here, we've got to find 15% of that. So let's write that down, 0.15 times 35.17. Okay, so this is the tip right here. Let's pull up our trusty calculator and do 0.15 times 35.17. And we get 528. So this is $5.28. That's how much the tip was. But it doesn't ask for the tip. It says, what's the final cost with the tip? So we have to add this to the original 35.17 in order to get that final cost. So we get that on there and add it to 35.17. and we end up with 40.45. So the final cost is 40.45. There we go. Notice that this being a forward problem, we were given all of the original numbers, the percent, the original price, and we did some arithmetic to produce the final answer. This is actually not an algebra problem. It will be included in your homework so you can differentiate it between this and the backward problem, but it is actually just an arithmetic problem where you're able to go forward. But it also, the reason we've done this and shown you here is because it shows us the pattern that goes on. Notice if we were to say original cost and call it a price, and this being the rate of being tipped, this is P plus R times P, and that equals our final price. This is the pattern. You can kind of make this formula up itself. You might also see in preparation for other courses that use, say, compounding interest or percent increases, many people will use a shortcut, P 1 plus R. So they'll take the rate, in this case 15%, add it to 1.15, and that will automatically include adding the price and the tip together. And so if you'd like to use that one's perfectly fine. And in the textbook, both of them are used so you can see how they work together and are exactly the same thing. These are the same, it's just a distributive property between those two. So let's see how that works with a backward formula. Problem. Here's one that is going to require going backwards. The population of a town decreased from one year to the next by 23% down to, notice this is our final right there. And that's what changes the whole problem. Here we were given the originals and asked to find the final. Here we're given the final and asked to use these other numbers to go back. So we have our data. Our variable. Well, P for population, I think. Now notice what it says, the population decreased by 23% of that population, and that's a crucial piece. You always take the percent times the original when you're doing percent changes. So percent minus 0.23p equals the final, 15,384. Now notice the formula then, if it's an increase, has a plus there, and if it's a decrease, has a minus. So that's what you'll see in the book. It could either be an increase up or an increase down from the original. But the key is you can't just take this times 23% and go back up, because it will be a different 23%. This is 23% of what it was to begin with. So when we combine these together, 1p minus 0.23p is 0.77p equals 15384. Notice where we are. We're in happy math land, and we can solve this thing. Divide by 0.77, divide by 0.77, and we get p equals, better pull out the calculator, 15384 divided by 0.77, and we get, the population used to be 19,979. And we're not going to put 0.2 on there because this is a population, so we'll round to the nearest person. So there we have it. And that's the three different kinds of percent problems. To the boards! And now it's time for you to give it a go. Here are the 4 problems you need to try. Pause the video, give them a shot, see if you can complete them, and then turn it back on when you're ready to move. Excellent, welcome back. So the first one says, if the lateral surface area of a cylinder is 238.5 centimeters squared and the height is 12 centimeters, what is the radius? Well, this is a shape. This has a formula, and we need the formula. We can go back to the appendix or up to section 1.3, and we'll get that, and we get this formula to pop up, and we're like, oh, here's where it is. Now, the grand thing about formulas is you don't actually have to do a lot of thinking. All you have to do is be able to put these in the right spot and see what we have. Height is 12 centimeters, so this 12 is going to go right over here. That's wonderful. And this 238.5, that's the lateral surface area, is going to go right in there. So we now have 238.5 centimeters squared equals 2 times pi times 12 times r right in there. 2 times pi times r times 12. We should note that right now, yeah, happy feelings. We are in math land right there. So let's go and let's get a calculator out here to see what this is. We need a calculator, and we need 2 times pi times 12. Let's see what that number is. 2 times pi times 12, and we end up with about 73.398. 75.398. Let's write that. 75.398 r equals 238.5. Okay, good. And we're in Mathland. We can do this. We can say, hey, what do we need to do to get the r by itself? And it's just one step. Divide by that 75.398. Divide by 75.398. And we end up with radius equals, oh, we better punch that in. We're going to take 238.5 and we divide that by, if you use this button, it will include all of these decimals. So divide by the answer and we get 75.398, 3.16. So we could round at 1 or 2 or 3 decimal places. Here we get 3.16, and let's make sure we get the units correct. Area is in centimeters squared. Height is in centimeters. The radius, it's a length, one-dimensional object, is centimeters. So there we have the answer. Excellent. Well, number 2, 189 is 38% of what? Now this is written out as an English thing and has direct translation. So we have 189 is, that's equals, 38% is 0.38 of what? And there's our variable. Call it x or n or q or p, something like that. And notice where we are. Yes, indeed. We just made an equation which we know how to solve. So divide by 0.38, divide by 0.38, and we get x equals, I don't know what that is right off the top of my head. 189 divided by 0.38 equals 497.36837, 497.37. 497.37. Excellent. And if instructions say to round at a different place, go ahead and follow those instructions. But if not, go ahead and round at 1 or 2 places, and that'll be good. All right, number 3. What was the final price? Notice what we're looking for. The final price of an object that has an original price. So here's our original, but is on sale, $49.30, but is on sale for 15% off. So first note that we have the original price. This is not an algebra problem, though if we wanted to use the formula, we could. And the formula is, it's a discount sale. The original price minus the rate times the original price is going to give us our final. Or you can just think through it and say, okay, if we take 15% of the original price, that's 0.15 times 49.3, that gives us our discount. We then have to subtract that from the original 49.3 to equal our final price. And you'll notice this is the exact formula that is in the instructions or in the textbook that you can follow if you would like to jump straight to there. And then we get, what do we get with that? Calculator time. 49.3 minus 0.15 times 49.3. And that gives us $41.905 and cents. We need to round to 2 decimal places, so 41.91. 41.91. So there you have it. If your price is $49.30 and you subtract off 15% of that, you'll get this. Now I would like to note there was a shortcut also presented that this is the same as P times 1 minus R. Notice that by the distributive property, these two formulas are exactly the same. So we could have taken and written it out as, let's do it in a different color so you can see it as a little bit different thing. 49.3 times 1 minus 0.15, which is the idea. If you take off 15%, then you're timesing this by 0.85. That's 49.3. Take off 15%, you have 85% left, and that's kind of what that math is doing right there. And if you punch this into your calculator, surprise, surprise, 49.3 times 0.85. So that's the same as timesing by 15%, subtracting off from the top, and we get the exact same number. So that shortcut is indeed true. That's kind of cool. I like that a lot. So let's go back to this one, number 4. On number 4, we get if a population grew, so we forgot to put our happy face right over here. There we go. If a population grew 17%. So we're going to be growing, this is a plus sign, 17% of something, better be of the original, from 2018 to 2019. So this is our original year, that's our final year. And there were 5,284 citizens in 2019. So this guy right here is our final amount. How many were there in 2018? So our variable is our original population. So we could use a formula over here, P plus rate times P, because it's growth, not sale, equals our final. Or we could think through it and say, ooh, we've got 17% of the population, that's 0.17 P, added on, that was the growth, added on to the original population equals our final, which is 5,284. Avoid that mistake. You cannot times 17% of 5,284 and subtract and go backwards. That won't do it because the 17% would be a different number when you times it by the original compared to timesing it by the final. So you'll notice there's also a shortcut here that is 1 plus R equals that. So you could have P times, let's write it down here the other way, P times 1.17 equals F. And notice what does indeed happen here. When you combine these like terms, there's that shortcut right there. So however you think best to get to this equation right here, recognize that you are indeed in a math equation, which we know how to do. So let's continue. Divide by 1.17, divide by 1.17, and we get P equals, oh shoot, 5284 divided by 1.17. Enter, and you get 4516.23. We're talking about people here, so just 4516. Round to the nearest person if we're dealing with population. Good. Now you're ready to take those kind of problems down in your homework, and now we'll proceed on to the last section. And the next kind is proportions, when things are similar to each other and have been blown up or decreased by the exact same rate every time. Notice this, a triangle has sides of 11, 14, and 20. A similar triangle, this tells you right here, hey, we are in proportions. There's a similar nature to them, so they have all in the constant ratio. It has corresponding sides of, so the 11 matches up with the X, 14 matches up with the 35, and the 20 matches up with the Y. So we draw proportions such as X is to 11 as 35 is to 14. And really all it is we're taking 35 divided by 14, and that's telling us the constant of proportionality, or the common factor that blew up one triangle, which was 11, 14, and 20, and it got blown up to a much bigger one, and this was a 35, and this was an X, and this was a Y. So we took 35 divided by 14 and gives us the number that has to be the same number as X divided by 11. And it's often said X is to 11 as 35 is to 14. Well, look at where we are. Happy math land. Let's solve this. Can we get X by itself? Oh, sure we can. Times by 11, times by 11, and we get X equals, oh, this fraction will reduce down into 5 and 2, right? 5 halves. So this is 5 times 11 is 55 over 2, or 27.5. That's what that X is. Cool, let's do it again with the Y. So we can go Y is to 20 as 35 was to 14. And again, that reduces by 7 over 7 down to 5 and 2. Can we solve this thing? Indeed we can. Times by 20, times by 20, and we get Y equals 5 times 20 is 100, divided by 2 is 50. So this guy over here equals 50. And there you have it. That's how proportions work. Just draw this is to this as that is to that, and you have an equation set up where you can immediately get rid of one of the denominators and solve for your variable. Now we get to some of the problems that become the most complicated with some of the easiest formulas you've ever seen. Distance rate problems. How do they make them so complicated? We have the basic formula, rate times time equals distance. Well, shoot, that doesn't seem so bad. If they give you a rate or a distance or a time and you can solve for the one you don't know, that seems pretty good. Well, here's a problem. Amber and Rick each took a trip. Oh, that's the issue. We have two people taking a trip. This is really two different problems. Amber drove at 60 miles per hour, so that's Amber's rate. Well, that's going to be an R thing. And Rick at 50 miles an hour, that's a different R thing. That's going to be a little complicated. Rick took 3 hours more than Amber. So at their time, Rick's is going to be three bigger than Amber's to reach his destination. If Amber drove 30 miles farther, oh wow, so that distance is changing. Yeah, see how many different things there are? So let's break this down and make it nicer. So Amber and Rick both have their own rate, time, and distance. Now let's not forget that rate times time equals distance. That is a pattern that will always hold. So let's draw a little table here and let's try to fill it out based on what we know and see if we can get it into Happy Math Land in an equation. So first of all, we know that Amber's rate is 60 miles per hour, and Rick is 50. Excellent, good, we got that. Now, before we go too much further, the second step here is the variable. Let's find what we are actually looking for. Notice it says how long was her trip. This is Amber we're talking about. We want how long. This is our variable that we put right here. We pick that to be our variable, and you could use Q, X, P, L, T, or N, I don't care, but T for time. We're looking for Amber's time. Now from this one variable, we just systematically go through and fill in everything we know how to fill in based on the clues we have. It says, what do we know about T here? We know that Rick took 3 hours more than Amber. So Rick's thing is whatever this guy is, but 3 more. So this is actually a T plus a 3. Now here is the slick trick. We have this multiplication here that tells us what these distances are. 60 times T has to be Amber's distance. 50 times this, 50 times T plus 3, must be Rick's distance. And now we look back up here, and this sentence right here gives us our equation. We know that Amber, however far she drove, which was 60 times T, has to be 30 further than, that's 30 plus, this 50 times T plus 3. Yeah, so this is Amber's distance right here, and this is Rick's distance right over here, and so Amber is 30 bigger than Rick. Ooh, that was a tricky one, but here's the key. You've got to pick the variable. That's the key right there. Once you pick the variable, then you've got to fill out the table. That's the key. Most people get messed up because they say if Amber drove 30 miles further than Rick, so they start putting another variable in here to fill out the table. But no, from one variable, you can fill out the entire rest of the table with this rate times time equals distance. Then this other clue about how their distances are connected will give you an equation. And look at where we are. Equation, Happy Math Land. Can you solve something like this? You're like, oh wait, I know how to do that. Are there any parentheses? Yes, indeed. Let's distribute. So we get 60t equals 30 plus 50t plus 150. Excellent. That's marvelous. Now, do we have any fractions? Nope. Do we have multiple t's? We do. So let's subtract this 50t over here, minus 50t, minus 50t. So we get 10t equals 30 plus 150. That's 180. Oh, look at that. Come and fall apart before our very powers. We get t equals 18. Holy smokes. What did we just find? T is Amber's time. So this equaled 18 hours. This guy, 21, man, they must have been going down across the country from Oregon to Texas or something like that. 18 and 21 hours. And you can actually try that and see if that is correct. Alrighty, let's work on the next one. These next problems are some of the funnest you've ever seen. People working together. Yeah, so as an example of how this works, let's say Jim, he can mow the lawn in, say, his time is, let's say, 6 hours. Yeah. And Jeff, he can mow the lawn in, say, 3 hours. Ooh, what happens when they're working together? What happens here? This problem throws people off and is one of the most difficult if you haven't seen it before. Well, partially because what's actually going on is hidden here. I'll show you what I mean. First of all, if Jim and Jeff, if you try to say, take these datas and say, not know what's going on, but say, let's add them and say, ooh, let's add them together, and what happens? Well, together it would take them 9 hours. Does that make sense that if they're working together, it would actually take longer than the slowest guy working all by himself? Nope. That doesn't make any sense. So don't add them. The next thing that will happen is you're like, oh, let's try to average them. 6 plus 3 is 9, divided by 2, 4.5 hours. Now, what's wrong with that? Well, does that make sense? Jeff can mow the lawn in 3 hours. And if he starts at one end and Jim starts at the other end, well, by the time 3 hours is up, even if Jim did nothing, they would finish it. Certainly 4.5. It's got to be less than 3. And so average isn't the way to do this. And so you're like, what in the world is going on? The secret lies in the fact that this is not a time problem. This is a rate problem. So the question really is, how fast is Jim working together? Jim working by himself, he's doing 1/6 of the job every hour. That's per hour. Yeah, and it's just the reciprocal. Yeah, you reciprocate that, and there you go. So Jeff is doing 1/3 of the job every hour. So this is how fast they are working, and the question is, how fast are they working together? So these guys actually add to this one. So we take 1/6 plus 1/3, which is, if they were actually working together every hour, Jim did 1/6 of the lawn and Jeff did 1/3 of the lawn, great. And we get 1/6 plus 2/6 is 3/6, which would equal 1/2. So every hour they get half the lawn done, so the time going back would be 2 hours. Fascinating. It goes over here through the rate. So the formula that you'll see is 1 over the first person's time plus 1 over the second person's time has to equal 1 over the total amount. So that's all you're going to be doing is reciprocating. So let's look at a problem from the text, that example there. If Wyatt can paint a house in 12 hours and Jeff can do it in 8 hours, hey look, Jeff's working with Wyatt now. How long will it take them if they work together? So this is going to be 1/12 per hour. So the reciprocal of this plus 1/8 is 1 over the total. There we go. So that's, let me see, common denominator here looks like 24. So that's 2 24ths plus 3 24ths is going to be 1 over the total time. And so we get 5 24ths equals 1 over the total time. So let's reciprocal on both sides. Can we do that? Absolutely. If these two numbers are equal, then their reciprocals have to be equal as well. So we get, what is that, 4.8 hours? Or 4 hours and, let me see, 48 minutes? 4 hours, 48 minutes, I think. If you take and times 0.8 by 60, you'll get 48 minutes. So there we have it. Sometimes you'll have to go backwards and say, okay, wait a second. If they give you the time working together, you'll have that number there, and then subtract one of these off to find the other one. Good luck with those. To the boards! Okay, here are the next 3 problems for you to practice on. Pause the video, do these problems, and then resume when you're ready to move on. All right, welcome back. Let's try it. Number 1, a 15-foot flagpole casts a 5-foot shadow, so 15 and 5. A tall tree in a park casts a 7-foot shadow at the same time. Ooh, let's draw this. So if we have a 15-foot tree doing a 5-foot shadow, it kind of makes a triangle here. 15 to 5, good. And a tall tree in the park casts a 7-foot shadow. Okay, so we got a similar triangle because the same time of day, sun's coming in at the same angle. Good. How tall is the tree? So let's put T here for tree. And Oh yeah, we can do this. Look at this. You could look at this one right here and say, oh, the flagpole's 3 times the size of the shadow, so the tree would have to be 3 times 7 would be 21 feet. Or, if we were doing it a little bit more officially, we draw the proportion. This is to that, so T is to 15, as 7 is to 5. 7 is to 5. Good. So now we have a happy math equation right here. Smile, ta-da, we have an equal sign, we got it. So what does that come out to be? How do we get t by itself? Well, we times both sides by 15, times by 15, and we get t equals, yeah, those guys cancel. T equals 15 divided by 5 is 3, 3 times 7 is 21. Yep, 21 feet is the size of the tree. Good. All right, the next one. Chris and Jeff work as janitors of a school. Chris can mop the floor in 2 hours. Oh, let's write these down. Chris, Jeff, good. And the time it takes right over here. So Chris can do it in 2 hours and Jeff can do it in 3 hours. How long does it take if they're working together? All righty. If they're working together, what time does that take? Now remember, the formula for this, you don't add them, you don't average them, but you have to find the rate at which they are working, and that's what we work with. Chris does 1/2 of the job every hour, Jeff does 1/3 of the job every hour, and these guys add, because every hour 1/2 plus 1/3 of the job is getting done. So let's do 1/2 plus 1/3. That will give us this number right here that we have to put over there. So that is 1 over the total together. Look how I capitalized that guy right there. All right, so 1/2 plus 1/3 equals 1 over this time. So what's 1/2 plus 1/3? Common denominator, this is 3/6. We'd have to times by 3 and 3, plus 2 and 2. So 2/6 equals 1 over t. So we get 5/6 equals 1 over t. So if we reciprocal both sides, we get 6/5 of an hour is how much time it takes together. So that's right there. So we should put a t there and a 1 over t there just so you can see how we got this equation and that formula there. So 6/5 of an hour, that's 1 1/5 hour. Is there any way to make that a little bit nicer? A fifth of an hour is, what, 12 minutes. So 1 hour, 12 minutes. Yeah, and you could just do that. You could put this as a decimal, 1.2 hours, and times 0.2 times 60, and you'll get 12. So there we go. Okay, the next one, number 3. Beth made a trip to her grandmother's house. So on the way to the grandmother's house and back again, good. On the way there, she was able to drive 65 miles per hour. There was a snowstorm on the way back that slowed her down to an average of 45 miles per hour. So she was going slower, and it took her an additional 2 hours. Alrighty, how much time did it take her to reach the grandmother's house? So going to grandmother's house, time is what we're looking for. So that'll probably be our variable right there, time. So we've got 2 different problems here. We have on the way to the house and on the way back. So we do this box. This is the favorite, and it will be the easiest way to understand what's going on. So we've got rate times time equals distance. Now notice where our variable is right here. It is right there. That's what we're looking for. How much time it took to go to her grandmother's house. So she drove 65 miles on the way there, and on the way back, the snow slowed her down to 45 miles per hour, and it took her an additional 2 hours. So this was t plus 2. We don't know how far she traveled to her grandmother's house. We don't even know the distance, but we can fill out this table. Rate times time equals distance. That's the formula. So rate times time, this would be 65t. And this one is 45 times t plus 2. Now here's the question. What do we know about these 2 things, these 2 distances? Well, the distance to a place and the distance back from it is the same. They're equal. So this is our equation right here. 65t has to equal 45t plus 2. So her rate at 65 miles an hour times whatever time, it has to be the same distance as 45 miles an hour times that time plus 2 hours. Okay, look at where we are, what we just made. We just made this happy math equation, and now we're going to finish it up. So get rid of parentheses We have 65t equals 45t plus 45 times 2 is 90. All right, so subtract 45t from both sides, and we get 20t equals 90. Divide by 20, divide by 20, and we get t equals 90 twentieths, which is 9 halves, which is 4.5 or 4.5. So time is 4.5 hours. And so that guy goes right up there. Now, if we wanted to, that's kind of fun. We got the answer, or I guess we could write it as 4 hours and 30 minutes. That's 0.5 of an hour. Again, 0.5 times 60 will give you the minutes. If you stuck in 4.5 right there, took 65 times 4.5, it would give you the distance. That would be the exact same thing as 45 times 6.5. Took her 6.5 hours to get back. Alrighty, that should do it. So you were able to take down your homework. Good luck.